Do you ever wonder how come you can have a perfect reflection of an image? So here I have an example of Lake Louise in Canada. We have the mountain up here, and the mountains here, the light is reflected on this flat surface of Lake Louise. No ripples. We have a perfect reflection of the what is happening here. You can see the trees and the trees down here. So this is a perfect reflection. So how is light working so that we can have such reflection? And that's what we're going to work with today. So first of all, if you want to have a chance, I'm going to put a link here to the last video about what is light. And light is part of an electromagnetic spectrum. Our eyes are specialized in gathering specific wavelengths of that electromagnetic spectrum. So here we need to know, how can we study that light? So the first thing we have to keep in mind is that if you have a light source, so let's see, I have a light source here. So I have a candle. That candle will have light. And light goes in all directions. So if you're in a party and you have a candle, the person in front, at the back, or on the side will all be able to see the light. Interestingly enough, light always goes in straight line, given what's happening on planet Earth. That means that if I have, for example, an object right here, a human on the other side would not be able to see the light because the electromagnetic waves are being blocked here. So here we will not be able to see the light. I know that some of you would say, well, if you look at stars, we know that the light of some distant stars sometimes can change direction when there is a black hole. I do understand that, but we're not talking about high energy physics here or black holes. If you're interested, put your comments below or your questions below. I'd be more than happy to answer you. So the question we have here is that if you take this light, this source of light, we have an infinite number of electromagnetic waves going in all directions. So the question here is, how can we study light a bit more? The best way to do is that if I can, from a source, from an infinite number of rays, if I can find a way to focus only on a few or focus on one, can this help me? And the beauty with that one is that if I can figure out what this light ray is doing, that will give me an idea of how this light wave would go, how this light waves would go, as well as all of these other ones. So when we are studying light in optics, in physics, instead of looking at all the situations, we're looking at one light ray or a few light rays and try to figure out what we can learn. So if we take this light ray here and we take a few that are beside, if we figure out what one light ray does, we can figure out what 8 does. And then we can put it in the 3 dimension, and then we have a good idea of how it works. So here I used a candle where light can go from all angles. Now, how can we get something that we can call a laser? A laser is interesting. A laser is usually a box where we have a light ray. Oops, let's see if I can, like this. So a laser would work where you have a little hole here where the light ray can go this way, and you may have a few that can go in. But what is interesting is as it goes in the box, on one end here you have a curved mirror. On the other end, you also have a curved mirror. So what happens is that all of these will be reflected. And then what happens is that you have lights that are being reflected over and over again, up to a point where it will all focus in one part right here. and then we have a specific, more condensed ray of light. So we have a source, and then inside the laser, there's a way for it to accumulate energy to a point where we can actually have a strong laser here. Often we think of red lasers, but you can also have blue lasers that have different wavelengths, and we can do different things from them. Now, if we can study one ray of light, that could tell us so much more about what's happening in physics. So let's see if we can look at what happens when you have light reflected on a surface. So let's see. Okay, so we have this way. We have this way. Actually, I'm gonna do something. This. Okay. In physics, when we talk about mirrors and rays of light, we often represent mirrors like this, where this is a flat mirror and this is the back of the mirror. This is a mirror that is not even, not flat. So what happens is that when we have rays that are going on the surface of the mirror, we're going to have reflections like this. So if we have this going this way, we're going to have reflection here. If we have another one here, we're going to have reflection. Now, earlier in this video, I showed a picture. So if you take up this picture here, we have light coming from the peak of this mountain. It's going reflected on this lake right here, and then the light comes to our eyes, which is interesting. So if you were to take this peak right here, this is a different point on the lake, and it comes to our eyes. These green trees here, they're going to the part here, and they come to our eyes. So when you're in art and you have a point of perspective, this is often something to keep in mind. Perfect. Now, what happens if you have an uneven surface of light? So that means that you have here, some of the light could be going back. Another one here, the light would go this way. This one will go here. This one will go there. So when you have an uneven mirror, or if you take, for example, you go to a lake and there's wind and the surface of the lake is uneven, you cannot really see reflection on its surface. You need a very flat surface to help us reflect the light. So is there a way to see the theory behind that? So that's what we're going to do in one moment. So let's see. So we have this. Perfect. So we're going to do this way. Perfect. Let's see if we can look at some vocabulary that could be useful. So that will be the reflective surface or a mirror. Is there one or two R? That's a good question. We have, so this is a plane mirror with two R's. Perfect. So when you have a plane mirror like this one, and we have a ray of light coming this way, it touches a point right here. So this is what we called an incident ray. So this is an incident ray. We talked earlier about the fact that if you have a light source, you have tons of different rays going through. Here we were looking at one only. So we have an incident ray. So light is going this way. Now, what is interesting when you think of this ray right here, there is an imaginary point that gives us a vector right here. And this is called the normal. The normal, do you put an E in English? No. So the normal is what? It is an imaginary line perpendicular to the reflective surface or the plane mirror. And it gives us an angle. It gives us this angle right here. We put a little eye right there, and it's called here an angle of incidence. Angle of incidence. So here this is the first part of our drawing. Now, what is interesting is that if you have light going this way on a plane mirror, we know that it's going to be reflected. But here the theory goes well. It shows that when we have a light ray going this way, it is being reflected this way. And this is called a reflected ray. Perfect. And interestingly enough, we have here another angle, and we call this one an angle of reflection. Angle of reflection, like this. Okay. So this is the base of pretty much everything we do when we have mirrors, when we have also refraction. It's going a bit beyond, but still the basics here of what we have is very important. So we have a plane mirror, we have an incident ray that is being reflected. Here we have an imaginary point, and we have here a line that is perpendicular that we call the normal. That is important because we have an angle between the normal and the incident ray that gives us the angle of incident, and then the reflected ray here will have an angle between the normal and this reflected ray. Interestingly enough, when we have a plane mirror, is that the angle here of incidence equals the angle of reflection. And that's interesting because if you look at what we have here later on, as we progress, you will notice that if you put something like this, you have a little triangle here and triangle there. And therefore, if we have triangles that are right triangles and we have angles, that means that we can use trigonometry to solve some of these problems. And that will be what we're going to study in the days to come. Some of you will say, well, trigonometry, I don't like it, but you'll see, you can look at all the trigonometry and you can simplify it to a point where it becomes very simple. You will see. If you've learned something amazing so far with respect to the reflection of light and its theory with the incident ray and the reflected ray, the angle of incidence, the angle of reflection, and the normal, please do not hesitate to subscribe to our channel. I bring in some topics about science. I use these topics from your questions from my students or the students that I tutor, because I love to share what I know and hoping that once you understand better, you will be able to succeed better. And that is part of how we can be better at school. On this, I'm going to put here a link to another video that you will love, and I'll see you there.